Hi girls, just another screencast for you on the measurement topic. This lesson, the volume of prisms and cylinders. Short one, but an interesting one. So the learning intentions, I understand what a cross-section is of a prism and a cylinder. I can find the volume of a prism and the volume of a cylinder. Hey, just before we get into it, just make sure that your notes, Mr. Wang gave you the booklet, so you turn your booklet to the page that I'm on, and once you're on that page, pause if you need to, then you can press go and we can get into it. All right, lesson starter, names of prisms. All of these things that you see here, all of these lovely coloured guys, are called prisms. And they're a special kind of shape because they have a uniform cross-section. What is a cross-section? A cross-section is, like for example, this guy here, if we look from the top, imagine we're looking from the top. What shape do we see? I hope you see that we see a pentagon, right? It's a five-sided figure, and a five-sided figure is called a pentagon. Now, let's slice another cross-section and take this one off and then look at what we would see from the same spot. We'd see another pentagon. So when you this guy here is called a cross section. So you're looking at him from a bit that's been sliced all the way through. Hopefully that made sense. So in the case of the, for example, this green cube here, we slice him off. We look down and we see a shape, and it's the same shape we saw when we looked from the top of the cube. We slice this guy in half. We look from the top, and it's a rectangle. This guy here, we're actually looking from here because the cross section is the same in this direction, and he's like a mini blue Toblerone. We take a slice through there. We take that one off. We look here again, and guess what we see? A triangle, just the same as before. That's what a cross-section is called. And prisms are named by the shape of their cross-section. So, what's the cross-section shape of this guy? It is a square. So this guy is called a square prism. What's the cross-sectional shape of this guy? It's a rectangle. So this guy is called a rectangular prism. What is the cross-sectional shape of this guy? He's a triangular prism. What is this guy? He's got five shapes. The shape of a five-sided figure is a pentagon. This guy is called a pentagonal prism. This guy has six shapes looking from the top, and he is a hexagonal prism. This guy, we can look from the top or the bottom. It makes no difference. He has eight sides. He's an octagonal prism. Prisms are named by their cross-section. All right, I want you to have a practice. This is actually a really good skill to learn when you're a year 8. It's how to draw prisms. So there's a couple of good techniques that I want to show you here in terms of how you draw them. Step 1, you draw the cross-sectional shape. Step 2, you draw the cross-sectional shape identical above and to the right. Could be to the left, but I draw it to the right. And then you join the corresponding vertices. So in the space in your booklets, I want you to have a go at these. Let's draw a rectangular prism. All right, step 1, draw a rectangle. Step 2, draw the identical rectangle above and to the right. That's about right. Step 3, we're going to join the corresponding vertices. Yeah? And there is a pretty good rectangular prism. Let's try a triangular prism. There is a triangle. There, above and to the right, is another triangle. let's join the corresponding vertices. Guess what? We've got a triangular prism. So if I was going too fast for you, then I want you to pause and have a go at doing these by yourselves, because it's actually a really good skill to be able to draw prisms, because you have to do it all the time. All right, pause now. All right, so let's work out how we calculate the volume of a prism. Well, you'll remember last time, in the last lesson, we looked at the volume of a rectangular prism, and a rectangular cuboid prism, and it was length times width times height. And I want you to remember that the area of the cross-section of a rectangle is length times width. So the volume of a prism is area times height. Length times width times height. It's the same for every type of prism. We're going to calculate the area of the cross-section. We multiply it by the height, and away we go. Base times height over 2 for a triangle. The area of a trapezoidal prism. This guy is a trapezoidal prism. So the volume is area times height. And in this case, because he's lying on his side, height is that dimension there. And the area of a trapezium, you might remember, is the other little h, which is this distance here, over 2a plus b. I'm going to just get rid of that bracket there for a second. I'm not sure it's adding any value. A and b. So what we do when we're calculating the volume of a prism is calculate the area of the cross-section whether it's a triangle or a pentagon or a trapezium or a rectangle, and then volume equals A times H. All right, let's do some examples. Here's a triangular prism. Now, we actually don't need to calculate the area of the cross-section because they've given it to us. So A is 6 meters. This guy here is the height. So area equals A times H equals 6 times 1.5 equals 9. What are our units? Meters. How do we measured area in squares. We measure volume in cubes. All right, well done. Now, this is a slightly more difficult one because what we've got to do is measure the area of this trapezium. The area of a trapezium is H on 2A plus B. And that's in your notes. Now, remember that you have your notes for the test. So don't feel like you're in trouble if you haven't remembered that formula, because as long as you recognise that shape is a trapezium, then you're in business. All right, what's H? H is the distance between the two parallel lines. A doesn't really matter which one is A and which one is B. I'm going to call it the small one A. So H is 2 over 2. A plus B is 2 plus 7. 2 over 2 is 1, so that disappears. 2 plus 7 is 9 meters squared, because that one is a measure of area. The volume of a prism is A times H. Is 6 because, sorry, not 6. A, we just calculated, is 9 times, and this one here is the height of the prism, which is 6. Answer, 54 meters cubed. Hopefully you finished my sentence there. All right, what I want you to do now is press pause, have a go at these next two by yourselves in your notebook, and then press play and see how you went. All right, we're back. All right, how the hell do you calculate the area of a hexagon? Well, good news. We don't have to because they gave us the area of the hexagon, yeah? So all we need to do is say volume of a prism is A times H. 32 times 11. Hey Siri, what's 32 times 11?
That would be 352.
352 millimeters. We measure area in squares. We measure volume in cubes. Volume in cubes. All right. Now, hang on. I just want you to fix up one error in the notes. This one here is not a trapezoidal prism. What sort of prism is it? It's a triangular prism. All right. So we know we've got to find the volume of this prism. Now we know volume equals A times H. How are we going to work out A? Well, I reckon that top shape there is a triangle. So we know that the formula for the area of a triangle is a half base times height. A half base. Now the base here will be this length here, and I hope you agree that that's the same as that one. So he must be 5 meters. Half times 5 times, and in the case of the triangle, this is his H times 2, which is 5 meters squared. We measure area in squares. Now, this one is another H because he's the height of the prism. So V equals A times H equals 5 times 3 equals 15 meters cubed because we measure volume in cubes. All right, so that's prisms. Now, there's a really special guy, which is sort of like a prism, but his cross-section is a circle, and his name is cylinder. So here's some examples of some real-world cylinders, yeah? Coke can, boom, can of whatever. So you'll remember that when we were calculating the volume of a prism, it was volume is A times H. Yeah, so for a shape like this guy, as long as he has a constant cross-section, so let's call this guy we'll call him a peanut prism. As long as he has a constant cross-section, then the volume is going to be A times H. Now, recall that the area of a circle is pi r squared. You all probably remembered that. So the volume of a cylinder, which is A times H, A equals pi r squared. H is H. So the volume of a cylinder is pi r squared. Pi r squared H. So hopefully that makes sense. Let's use that formula to try and calculate the volume of these cylinders, I should say. So to 2 decimal places. Here we go. Formula, substitute, answer. Volume equals pi r squared H equals pi times the radius of the circle is 4 squared times H. The height is 10. So that's R and that's H times 10. Hey Siri, what's pi times 16 times 10?
3.1415 times 16 times 10 is approximately 502.6548.
All right. Now, we want 2 decimal places here, don't we? So let's work out our rounding. We'll have a look at our critical digit. Our critical digit is 4. So it's not 5 or more. So we leave the 5 unchanged. Equals 502.65. What are our units? Meters cubed for volume is measured in cubes. All right. Here's another tricky one. So we're going to start with formula, substitute, answer. But before I do, I'm just going to work out if that distance there is 18. I reckon that's 2 radius. I think that's a diameter. So I have to work out I reckon the radius is going to be half that. And half of 18 equals 9 metres. Yeah? And I reckon this guy here is the height of my prism. He's just lying on his side. So volume equals pi r squared h equals pi times 9 squared times 23. We want 2 decimal places. Hey Siri, what is pi times 81 times 23?
3.1415 times 81 times 23 is approximately 5,852.7871.
7871. Let's get the rounding right because we need 2 decimal places. So we're going to put a little line there. Have a look at this critical digit. He's a 7. 7 is 5 or more, so we're going to round this guy up. 5852.79 meters cubed. There we go. All right, so have a go at these next 2 by yourselves. Pause the video for a second, and then I'll show you how I went. All right, have you got your answers? Hopefully what you started with was volume equals pi. Oh, actually, we don't need to use pi r squared h here, do we? Because they've given us the area. So we can just say AH equals 12. A equals 12 times 10 equals 120. And our units are millimeters cubed. Millimeters cubed for volume. I reckon this next one here, that again, they've given us the diameter. I reckon the radius is 3.5. This one, we do need to use that proper formula. Volume equals pi r squared h equals pi times 3.5 squared times 10. Now, again, he's lying on his side, so that's why that horizontal distance is still h. Hey, Siri, what's pi times 3.5 times 3.5 times 10?
3.1415 times 3.5 times 3.5 times 10 is approximately 384.8451.
All right, thank you, Siri. So let's have a look. We want 2 decimal places. This is the critical digit. Is it 5 or more? Yes, it is. So we're going to need to round this up to 384.85. What are our units? Meters cubed. There you go. I hope that all made sense. So that's how you calculate the volume of prisms and cylinders. So have a go at the practice exercises for chapter 4I. They're all on page 4I of this booklet. And if you have any problems, feel free to send me an email and we'll sort it out.